Hello my dear students, welcome back to Learn Physics. In today's topic, we are going to discuss about the mean value of AC and RMS value of AC. First, we are going to consider about the mean value of AC. What is meant by mean value of AC? Here, this is the representation of AC. One AC wave in a period of time, capital T. For that, I am considering the time interval T by 2. So here in this time interval T by 2, that is in the case of a half cycle, what is the mean value of current? Mean value of AC. So mean value of AC means mean value of the current. Okay, in this half cycle. Okay, then what we will consider there? We will be considering a steady current which will give the same number of charges. See, for making this much of, for getting this much of mean current, how much charge is required? The same charge if it is passing through this steady current. What will be the amount of current? That is called a mean value of AC. Value of steady current which would send the same amount of charge through a circuit in the time of half cycle as sent by AC through the same circuit. Simply we can say in T by 2 time interval, what will be the mean value of current which is passing through the AC circuit. Okay, that means if Q amount of charge is required to make this much of current in a steady current, then what will happen to the AC? What will be the mean value of current? For that many number of charges, how much of mean current will be making in that AC circuit? Okay, for I is the current in the steady circuit while we are considering. If I is the total current, then this I, to provide this I current, I amperes of current, if we required Q amount of charge, that Q amount of charge if I am giving to the AC half cycle, how much will be the current produced, mean current produced in the AC circuit? That one we are going to find out. So in short, we are going to find out the charge. What will be the total charge required, the charge which will be there to see in the 0 to T by 2 time interval, what will be the total charge. For that, I am considering if for a dt time interval, what will be the current charge? dq will be equal to I into dt. Then what will be the total charge in the whole, that is from 0 to T by 2 time interval? What will be the charge? I dt. What is the value of I in the case of AC circuit? I equals I m sin omega t. Right. So here I can write it as I0 is common, integral or Im as common, sin omega t dt. 0 to T by 2. Sin omega t is minus cos omega t minus cos omega t into omega. So integration, right? So divided by omega. 0 to T by 2. Now I am taking omega outside. Im by omega cos omega, instead of t I can write it as T by 2 minus cos 0. Right. Now I know this t equals 2 pi by omega. So what will be omega? This omega will be equal to 2 pi by t. Therefore minus Im by omega. 2 pi by t, if I am writing over there, we will be getting it as cos 180. Okay. Omega 2 pi by t into T by 2. T and T will get cancelled. 2 and 2 will get cancelled. So we will get it as cos pi minus cos 0. Cos pi is cos 180 minus 1. So we will get it as 2 Im by omega. This is the total amount of charge. Okay, 2 Im by omega is the total amount of charge which is in this circuit. So from there we can find out the amount, what is the maximum value of current, that will be equal to Q into omega by 2. Like that also we can write down. This is the total charge. Now our aim is to find out the mean value of current. This is the maximum value of current in the T by 2 second is 2 Q omega by 2. Like that also we can write down. Now if I mean is the mean value of AC in the half cycle, that means for T by 2 time interval, if mean value is I mean, what will be the charge in that, I mean value, how many number of charges or amount of charge in this mean value of current. Q equals, we know I is equal to Q by T. So the charge will be equal to I mean into time is T by 2. So this is the charge if we are calculating in the same. See, simply if I mean is the value of current in this T by value of charge in this, see, half cycle while we are considering, I mean is the mean value of current, then T by 2 time interval. So I mean into T by 2. Now we can equate these two because this one we found out in this method, and here we are giving directly I mean value and getting the value of Q. Now I can equate these two Q's, right? So I'll be getting it as 2 Im by omega into, that is equal to I mean into T by 2. So here we will be getting it as I mean equals 4 into Im divided by T omega. Okay, here 4 into Im divided by T into omega is 2 pi by T. Right. So here we will get it as 2 Im by pi. Or that can be equal to 0.637 Im. So it will be this mean value of current AC value in the half cycle will be equal to 0.637 Im, or we can write it as 63.7% of the peak value, maximum value. If maximum value, if I am writing it as Im, 63.7% of mean value will be, this peak value will be there for this mean value of current in the first half cycle. Clear? So this is how we will be finding out the mean value of AC. So here you should understand the concept that 63.7% of the mean value or maximum value will be given for the mean value of current in the AC circuit. Okay, mean value of current in the half cycle is equal to 63.7% of the maximum value or peak value. Now, what will be the RMS value? RMS value means it is the root mean square value. Okay, first we will take the square, then we'll take the mean, then we will be taking the square root. So the simple way to produce, see, we can find out the RMS value in different way. First one by using H is equal to I square RT. In that method you can find out, but that is little bit difficult. The easy way is simply you can take the value I equals Im sin omega t and then take the square value and then mean, then take the square root. So now we are going to do in that way how we will be getting the RMS value of AC. Now the root mean square value of AC current. Okay, now or alternating current, I equals Im sin omega t. First we will square, this is the first step, then we will take the mean, then we will take the root. So I square will be equal to Im square sin square omega t. Now we will take the mean value of I square, that is equal to Im square sin square omega t. Im as constant, so Im square into sin square omega t, I can write it as 1 minus cos 2 omega t divided by 2. Okay, this 2 we can take it outside, Im square divided by 2. See, what will be the cos 2 omega t average? Cos 2 omega t average is equal to 0. Okay, last class I told you it's the explanation is not required. If it's required, you can just go through the textbook. It's given in the last line. Okay, what is the how? That is actually you will be studying that in the mathematics also. So average of cos 2 omega t is equal to 0. So we will get it as Im square by 2. Now we should take the root. So IRMS will be equal to square root of average of I square. That is equal to square root of Im as Im divided by root 2. Or 1 by root 2 is 1.147, right? So 0.707 Im, or we can write it as 70.7% of Im will be IRMS. Okay, so RMS value in the case of AC, whatever we are getting it as peak voltage will be equal to IRMS. What is there in the supply? Supply voltage. What is the supply voltage? That will be the RMS voltage. Otherwise they will say peak value of current is this much. That means Im value is given as peak value, and IRMS will be the, say, 220 volt supply or 150 volt supply. That means that 220 volt and 150 volt and all for RMS value. RMS value will be 70.7% of Im. Thus mean value will be 63.7% of Im. Clear? So now we are going to do some of the numericals which we didn't do for our LCR circuit, which I discussed in the previous class. Okay, shall we do? The first question is, a capacitor of unknown capacitance, a resistance of 100 ohm and an inductor of self-inductance 4 by pi square Henry are connected in series across an AC source of 200 volt and 50 hertz. Calculate the value of capacitance and the current that flows in the circuit when the current is in phase with the voltage. Okay, so the given datas are, resistance is given as 100 ohm and an inductor of self-inductance 4 by pi square Henry, and then connected in series across an AC source of 200 volt. So here V equals 200 volt, that is VRMS, that is equal to 200 volt. Now 50 hertz, frequency is given as 50 hertz. Calculate the value of capacitance and then current that flows in the circuit when the current is in phase with voltage. When current is in phase with voltage, when current will be in phase with the voltage, when R will be equal to R alone is in the circuit. So current also we need to find out, that is RMS value of current we need to find out. Here we should find out capacitance, and IRMS we should find out when this voltage and current are in phase. In which context we will be getting this current and voltage and phase with each other? Yes, if resistance alone is present over there. Then in an L, here they are telling about inductance, capacitance and resistance. Okay, we know Z equals root of R square plus XC minus XL the whole square. Right, if both are in phase, what will happen? This R alone is present. If R alone is present means XC minus XL will be equal to 0. That means XC is equal to XL. Or we can write, what is the value of XC? 1 by omega C. That is equal to L omega. Omega equals root 1 by root LC. Okay, here we are getting this formula. From here we can find out the value of C, that is omega square 2 pi into nu. Nu is 50, the whole square into L. L value is 4 by pi square. that is equal to 1 by C. Clear? So we can find out C equals 1 by 4 into 4, 2 into 50 the whole square into pi square into pi square. Pi square will get cancelled. This is for the value of C. So 10 to the power minus 6, 25 into 10 to the power minus 6 farad, or capacitance we will get it as 25 microfarad. So this is how we should solve this one. And the next one is we need to find out the RMS value of current. IRMS, how we can find out IRMS? VRMS divided by Z. Here Z in an RLC circuit we will be writing it as impedance Z, right? So here VRMS we got it as 200 divided by XC minus XL is equal to 0. Therefore only R we need to consider. It is R is given as 100 ohm. So it is 2 ampere. Clear? Next one, a series LCR circuit is connected to an AC source 200 volt 50 hertz. So VRMS is equal to 200 volt and frequency equals 50 hertz. The voltage across the resistor, capacitor and inductance are. So V across the resistor, inductance, resistor, capacitor and inductance are given like this is VL. 200 volt and this is 250 volt and this is 250 volt. The algebraic sum of the voltages across the three elements is greater than the source. Why? So algebraic sum of the voltages across the three elements, that is VR plus VC plus VL is greater than VRMS. Why? If R equals 40 ohm, calculate the current in the circuit. R equals 40 ohm, we need to find out the current. So here first one, why this is like, say VR plus VC plus VL, if we are taking the algebraic sum, that will be greater than the VRMS, but the circuit voltage is given as 200 volt only. What is the reason? Yesterday we told about the voltages. See, resistance is acting like this, voltage across the resistance, and capacitor is acting like this. Just opposite to that, inductor also acting. Right, while we are considering about the resistance, voltage across the resistance, VL will be pi by 2 ahead and VC will be pi by 2 lagging behind, pi by 2 lagging, and VL will be pi by 2 leading. So VL and VC, here while we are considering VL and VC, so these two are same. VC and VL are same. So this will be cancelling each other, right? VC and VL will get cancelled. VR alone will exist. That is 200 volt. So that is 200 volt. So this is the reason we are getting the algebraic sum as greater, but actually the voltages are same. It will be cancelling while considering the vector addition. Now we need to find out I value. How we can find out the I value? I will be equal to V by Z. Z equals root of R square plus XC minus XL the whole square. But here we know it as XC and XL are equal. That is why we are getting the voltages as same, right? So XC and XL are equal. This won't exist. Only R will be existing. So we will get it as R. I is equal to 200 divided by 40. So the answer will be 5 ampere. Clear? So this is how we will be solving this one. So clear for you, and then tomorrow we will be coming with the resonance. Okay, resonance in this circuit, how we will be explaining. Actually, we can, this previous question, right, which I did earlier, that previous question was explaining about this and this also. No, this also explaining the resonance. Okay, that one we will discuss in the next class. I hope it is clear for you, and in this session you should understand what is mean value of current and RMS value of current. Mean value of current is 63.7% of this total current in the half cycle. Okay, and RMS value of current will be 70.7% of this mean current. Okay, and this formulas also. I is equal to V by Z, Z equals root of R square plus XC minus XL the whole square. I think it is clear for you, and if you like the channel, please don't forget to subscribe, like and share. Thank you for watching. Bye.